All right, let's talk about adding fractions. And we're going to do it several different ways. I think you should pick a way and be really good at it. So one of the new methods I've seen, I call it new because I really hadn't seen it until just recently, is to multiply. So you're going to start here, and 2 times 4 is 8. So that's where you get this 8 on the bottom, and then 4 times 1 is 4. So we're converting 1/2 to 4/8, and we did it by multiplying this way for the denominator and that way for the numerator. Now for this one over here, we're going to say 4 times 2 is 8. There's the 8, and 2 times 3 is 6. So that gives us a common denominator, because when you're adding fractions, you have to have a common denominator. That's why we can't just add these straight across here. Anyway, now that you do have a common denominator, 4 plus 6 is 10, so we have 10/8, and we can reduce that. 2 goes into 10 5 times, 2 goes into 8 4 times, so we have 5/4. So that's the answer. And if you want to change it to a mixed number, you can. 4 goes into 5 one time. 1 times 4 is 4, plus 1 more is 5. So these are the same thing, just written 2 different ways. So 5/4 as a improper fraction, and 1 1/4 as a mixed number. I don't actually like the terminology improper fraction, because there's really nothing improper about this. It's just fine. I would just call it a fraction, but in the past, people have called it an improper fraction because they didn't like having a bigger number on the top, so you would swap it over. Anyway, that's that. So that's kind of a newfangled method I saw. Let me show you the way I learned how to do this as a kid back in the 60s and 70s. 1/2 plus 3/4. Same thing. You have to have a common denominator to do it. So you look at 2 and you look at 4 and you ask yourself, what is the smallest number that both 2 and 4 will divide into evenly? And that is 4. So we put a 4 down here. Now, pretend like these numbers aren't here, but we put a 4 down here. So we're going to change these fractions into equivalent fractions that have a denominator of 4. So where you get the 2 is this. This is what we did. We said, how many times does 2 go into 4? And that answer is 2. So 2 times 1 is 2. So 1/2 becomes 2/4. Let me say that again. How many times does 2 go into 4? In other words, what times 2 is 4? And that's 2. So 2 times 1 is 2. So we would transform this 1/2 into an equivalent fraction of 2/4. Of course, we don't have to do anything to this. We just bring it down because it's already a 4th. And again, 2 plus 3 is 5. So that's 5/4. And yes, you can convert that to 1 1/4. Now that's the way we did it when I was growing up. I like that. You have to be fairly smart. There's a bunch of things you're teaching here about division. There are things that you're teaching about, like what's the smallest number that both of these will go into. So divisibility rules, like we had to know a lot. Even though our grades weren't that great, because back then grading was tough. They went through a change, I think, in the 60s and 70s to where they upped the requirements. And so, our grades didn't look good, but we actually knew a lot. Anyway, so let's look at another method, and I think this might actually be my favorite method. So pretend like this is not here for right now. So we have 1/2 and 3/4, same problem. And what you're going to do is look at these, look at 2 and look at 4, and you want to have the same denominator. So think about what would be the easiest way, again, pretend like this is not here. What would be the easiest way to get these to both be the same number? And hopefully you see that if you just multiply this one by 2, it would be 4. So if you multiply by 2 here, you have to multiply by 2 on the top. That way you're really multiplying by 1. 2/2 is 1. And if you multiply by 1, you don't really change the value of something. You change the way that it looks. So that's what we're doing here. We're saying, hey, there's a 2, there's a 4. We need these to be the same, so I'll multiply this by 2. That way I'll get 4. But whatever you do on the bottom, you have to do on the top. So 2/2. So this 2 times 1 is 2. 2 times 2 is 4. So we get 2/4 that way, which I really like that. I think in terms of today's students, that's probably the easiest way to get a least common denominator. Anyway, then you add these together like we've been doing, 1 1/4. And by the way, let's have a little bit of number sense here. Here's 0, here's 1, here's 2. This is halfway between 1 and 2. This is a quarter of the way between 1 and 2, and this is 3/4 of the way. So 1 1/4 is about right there. So 1 1/4, that's how big 5/4 is. So this is a little bit about adding fractions. If I were you, I would go back through these methods. I think it would be good to understand all of these methods and then teach one of these methods. What I don't like about this one is, I mean, this method is super easy, but you do have to reduce at the end. And in my experience as a teacher, sadly, kids are not very good at reducing fractions. I mean, so on the one hand, you could teach this method and teach them to reduce. So, you know, press through. So I don't think it's a terrible method, even though you have to reduce. This is the way I was taught. It's old school. It works. I wish people understood it. Largely, people don't. So I live with it. And if I had to teach this, I'd probably teach all these methods, but honestly, I would probably harp on this every single day because I think that it's just an easier method. And though I'm old school, I don't think that we necessarily need to beat kids up or to make their lives difficult. I think teaching the easiest way is probably the best thing to do. So there's that. Now, one more thing. The trusty Texas Instrument 30X2S. If you turn this bad boy on, now watch what I'm going to do. So I'm going to do the same problem. Or try to do the same problem. I'm going to do the same problem. So 1/2, you hit the 1. Can you see that on there? 1. And then this button up here, this trying to get that to focus. It's an ABS button. It's right underneath the PRB, the probability button. So if you hit that button, notice what kind of, see that symbol? So 1/2, that's how you represent 1/2 on this calculator. Now I'm going to hit plus because we're adding, and now 3/4. So 3, and then that button, and 4. So it looks like that. Now if I hit enter, it gives me the answer, and that means 1 1/4, that symbol. So 1 1/4. So these calculators will add the fractions as well. Now, I do think you need to teach children to add fractions. I do. And I think you could make up a ton of problems and you could check them using this. You could even have your kid do a ton of problems where they're adding fractions and then they're having to check it on the calculator. Now that would reinforce several things. That would teach them how to do it, and then that would teach them also how to do it on the calculator, but they would be able to provide their own check so that you're not having to come behind them and see, you know, is the answer really right? They could check it themselves, and if they're not getting them right, then it means that you need a little intervention and you need to work with them some more and until they can do this consistently over and over and over and over again to be able to add fractions. By the way, the same thing works with subtracting fractions, though it's a little bit more difficult. We'll do a video on that sometime where you've got minus involved, but very similar concept. Anyway, so adding fractions is important. I noticed that even when you get to, say, Algebra 2 and you're working with quadratics and you're having to find points on the graph, sometimes you have fractional values, and students have a very difficult time graphing a quadratic, but it's not because they don't know how to do the Algebra 2. Often it stems back to this, like they really aren't comfortable adding, subtracting, multiplying, and dividing fractions. Well, that's enough for today. See you later.